That answer used to confuse a lot of people. Maybe you've seen the strawberry example, maybe you've even tried it yourself. Today, most AI models get it right, but for a long time, they didn't. And I wanted to understand why. So at first, I assumed this was just another funny AI bug, but the more I looked into it, the stranger it became. Because there wasn't just one explanation, there were dozens, and almost all of them pointed to the same thing. Honestly, it sounded convincing, so I decided to verify it. Every explanation I found eventually led to the same place: tokenization. So instead of taking everyone's word for it, I wanted to see it myself. Okay, so before the model ever starts answering, your text gets broken into pieces called tokens. Those pieces, not the original word, are what the model works with. So if the individual letters aren't directly available, it seems reasonable that counting them would be difficult. Honestly, I thought I'd found the answer. But then I realized something. If that's really the reason, there's an easy way to test it out. So if tokenization is really the problem, we should be able to fix it, right? Think about it. If the model cannot see the individual letters because of tokenization, all we have to do is make the model see those letters. And once that is done, it should be able to fix it, right? Let's verify. That shouldn't have happened. The model just proved that it knows every letter. So the letters were never the problem, at least not the whole problem, which means everything we thought about was incomplete. Watch what actually happens when you count. You do not just recognize letters, you carry a number with you. Every step depends on the one before it. So without that running count, the process falls apart. That's because counting isn't just recognizing information, it's remembering something while moving through a sequence. So a language model generates text one token at a time, but inside each prediction, it doesn't count the way we just did. There isn't a little counter moving from letter to letter. Its job is different. It's trying to predict the next token from everything it already knows, not maintaining an exact running tally. That's why the experiment mattered. The letters weren't missing, the process was. And once I saw that, the behavior finally made sense. At first, this felt like a contradiction. If the architecture hasn't fundamentally changed, why did the answer suddenly become correct? The biggest difference isn't that the newer models suddenly learned a perfect counting algorithm, it's that they are much less likely to jump straight to an answer. Instead, they create intermediate steps. Those steps act like the running counter we saw earlier, not because someone explicitly programmed a counter, but because the model learned that breaking the problem down is more reliable than guessing. The important change wasn't the letters or the question, it was the process used to arrive at the answer. And that was the missing piece. The letters didn't change, the task didn't change, the process changed. And once the process changed, the answers started changing too. I started this video trying to answer a very simple question. Why could an AI do all of this and still fail at counting a few letters? It turns out counting letters was never the interesting part. The interesting part was discovering that knowing something and executing the right process aren't the same thing. Once I stopped asking, is the model intelligent? And started asking, what kind of computation am I asking it to perform? Its behavior become much easier to predict, not just for counting, for a lot of things. That's probably the biggest thing I took away from this. Next time when an AI answer surprises you, maybe you have to look in a different way. Maybe ask what is the process that it is taking to get that answer, and usually that changes how we actually perceive those answers. Funny enough, this was never really a video about counting. It was about understanding why a seemingly simple task could expose how language models actually work. I'm Kishan, thanks for watching. I'll see you in the next one.